Hello all, I am Dr. Pravas. In today's class, we'll discuss about the syntax directed translation. Okay, we have already discussed about the syntax directed translation in the previous class. Okay, so here we'll discuss one more example of syntax directed translation. Okay, say, just try to understand what is the meaning of the question. Say, construct the STT that calculate the total number of, this is very important, that calculates the total number of reductions, taken by the parser for the input string it derives. Okay, so here in this question, the question acts like this. What? Calculate the total number of reductions by the parser. Total number of reductions. Where red is an attribute. Here attribute name is red. Red means reduction, we can say. In short, it is called red. Red is an attribute, and e dot red is the root value. And e dot red is the root value would give the total number of what? Reduction value. Then write the semantic rules by considering the following grammar. This one is the grammar. Okay, this one is the grammar. So we'll write. So question acts like this. What? Calculate the total number of reductions taken by the parser. Suppose I am taking just one example. Suppose just say id plus id star id, right? So how many reductions are possible? Just see how to find. We have already discussed about how to calculate the number of reductions in the previous class. Okay, so you can check. So id, just see, we can reduce this id value. We can reduce this id. Id means id reduced from f, or id derives from f. So this is f, this is plus, this is id, this is star, this is id. Okay, so similarly we can reduce this id. Okay, so f plus, this one is f star id, right? So similarly we can also reduce this id. This is f plus f star, this f means id means f. Okay, similarly we can reduce this f. This is t plus f star f. Okay, similarly this we can reduce this f. This is t plus t star f. Similarly we can reduce t star f. How? This t star f reduced from where? T. So this is t plus, this is t. Similarly this t we can reduce, t reduced from where? E. E plus t. Similarly we can reduce e plus t. E plus t derives from where? E. So this is the called as the reduction. So how many reductions total? 1, 2, 3, 4, 5, 6, 7, 8. So total number of reductions are 8. So actually the questions are like this. What? The question asks, just count the total number of reductions. Okay. So we'll construct the syntax directed translation that STT to calculate the total number of reductions. Okay. So I'm just erasing this one. Okay, just erasing. Now we'll construct the what? First step of HTT is First step of HTT is to construct the parse tree. To construct the parse tree. Just see here, red is an attribute. Here, red is an attribute. Red is an attribute. Okay. So red is an attribute. I'm just taking one example. What? Similar example, just like ID plus ID star ID. I'm just taking one example, ID plus ID star ID. Okay. See, first step of HDT is what? First step of HDT is to construct the parse tree. So we'll construct the parse tree for the input string. Give in input string what? E2 what? E plus T. Then we'll construct this T2 T star F, then E2 T T2 F F2 ID T2 F F2 ID, here F2 ID. Okay. So see, this is the parse tree for the given input string. This is the parse tree for the given input string. So now what is the second step? The second step is to construct the annotated parse tree. Annotated parse tree means what? We just add the attribute. We just add the attribute information. Means what? F dot red, F dot red, F dot red, T dot red, is T dot red, E dot red, T dot red, E dot red. Okay. So let's see, I'm using one more color. Okay. Right. So now just see F2 ID, F dot red equals to ID. Means this one is one reduction. So F dot red equals to 1. Similarly, F dot red equals to 1. This is one reduction, and F2 ID, this is one reduction. So that means we'll assign what? F dot red equals to 1. What? F dot red equals to 1. We just simply assign. Okay. So here means for here in the here means for a T dot red case. Here we'll reduce 1 means F2 ID. Then here this to this means T to F. This is one more reduction. This is one more reduction. This is one more reduction. This is one more reduction means T to F means one more reduction means here 1 and here this is 2. Okay. So similarly we can check here T to F, F2 ID, this is one reduction, but here this is one reduction means T to F, this is one more reduction means this is 1 and this is 2. Okay. So that means what? T dot red equals to what? How to get T dot red equals to 2? How to get T dot red equals to 2? So T dot red is nothing but it is F dot red plus 1. What? T dot red equals to F dot red plus 1. Okay. Just say E dot red. Here this is one reduction, this is one reduction, and here this is one more reduction. So means here 2. That means here 3. So there are 3 reductions in the left side. This is one reduction F2 ID, 2 to F, T to F is one reduction, and E to T is one reduction means in the left part. So E2, how to get E dot red equals to 3? E dot red is nothing but T dot red plus 1. So E dot red equals to t dot red plus 1. Okay, so left part is over. Now we'll check the right part. F dot red, sorry, F2 id, this is 1 reduction. T2F, this is 1 reduction, means 1 plus 1 equals to 2. Just say F2 id, this is 1 reduction, so F dot red equals to 1. So T dot red, just see, this is 1 reduction, this is 1 reduction, this is 1 reduction, means total 3 reduction, including T, means T to T star F. This is, here it is 4. How to get 4? Just see, F2 id is 1 reduction, T to F is 1 reduction. Just see, I'm again writing F2 id is 1 reduction, T to F is 1 reduction, this F2 id, this one is 1 reduction, and T to T star F, this is 1 reduction, T to T star F, this is 1, means here total number reduction is 4. So just write 4. So in the right part, the total, means in the right part, the total number of reductions, in the right part only, means this part, the total number reduction is 4. In the left part, the total number of reduction is 3. So how to get T dot red equals to 4? Simply, T dot red is nothing but what? T dot red, this one, plus F dot red plus 1. That means T dot red equals to T dot red plus F dot red plus 1. Means T dot red, this one, this value is 2, F dot red, this value is 1, 2 plus 1 plus 1. So T dot red equals to 4. Okay. In the left part, there are 3 reductions. In the right part, there are 4 reductions. So one more reduction, just see, E to E plus T, E to E plus T. So in the left part, there are 3 reduction. In the right part, there are 4 reduction. So including E to E plus T, so the total number of reduction means E dot read equal to total, 8, total 8, right? Total 8. So how to get E dot red equals to 8? How to get E dot red equals to 8? So E dot red is nothing but E dot red plus T dot red plus 1. E dot red equals to E dot red plus T dot red plus 1. Okay. So in the right part, there are 4 reductions. In the left part, just see the reduction. This is the first one, means F2 id, T to F, then E to T. Okay. So this is 3 number of reductions in the left part, 4 number of reductions in the right part, then E to E plus T, E to E plus T. This is 1 reduction, means 3 plus 1 plus 4 equals to total number of reductions are 8 reductions. Okay. So this one is called as annotated parse tree. Annotated parse tree. This one is called as context free grammar, and this one is called as what? Semantic rules. Semantic rules. Okay. So this is the given STT. This is the given STT for the means for the calculation of total number of reductions are present in the given in any input string. Okay. Now we'll see one more example of STT. Let's see. Construct the STT to calculate the height of the parse tree. Okay, this is very important. Means this STT will calculate the total number of what? Height of the parse tree. For the input string, it derives. Where HT is an attribute. Just see, HT is an attribute, where ht is an attribute, and e.ht would give the total height of the pass tree, then write the semantic rule by considering the following grammar. These are the grammar, so we'll write. Okay, so important point is here, this HDT will construct the HDT for what? To calculate the height of the pass tree. Okay, first we'll take one example, one of the input string. Okay, let's see. Okay, we'll take one input string, what? ID plus ID star ID. Okay, this is the input string. For the given input string, first we'll construct, what is the rule for HTT? First we'll construct the parse tree. Okay, this is the given input string. We'll construct the parse tree. We'll construct the parse tree for the given input string. Okay, see. E plus T, then T star F, then E to T, T to F, F to ID, T to F, F to ID, F to ID. Okay, so this is the first tree. For the given input string. Now what is the second step for HTT? Now we'll construct the annotated parse tree. Annotated parse tree means simply just add the attribute information. In each node. So f.ht, or f.ht, h dot ht dot ht dot ht dot ht dot ht. Okay, so here we'll calculate the height of the parse tree. Okay, just say f2 id f.ht, here height is 1. Just see, here height is 0, here height is 0, here height is 0, because at the leaf node the height is always 0. f.ht, here height is 1, here height is 1, here height is 1. Okay, let's see. So that means what? f.ht equals to, how to get f.ht equals to 1? We just simply assign f.ht equals to 1, f.ht equal to 1, f.ht equals to 1. Okay, here f.ht equals to 1. Okay, so then just see, here in this case, at this node, means here in this node, here height is 2, here height is 2. Just see, in this node the height is 2. How to get the height? Means t.ht equals to, simply add f.ht plus 1. So t.ht equals to f.ht plus 1. Okay, let's say in this node, means e.ht, here height is 3. So how to get e.ht equal to 3? E.ht is nothing but t.ht plus 1 simply. So e.ht equals to t.ht plus 1. Okay, now we'll see. In this case, here in the right part, the height is here 1, 2, 3. So here height is 3. Here height is 3, means t dot st. So in this case, how to get t dot st equals 3? Just say find the max between t and f. What is the max value? Max value is 2. 2 plus 1. Find the max and max value plus 1. So that means, so t dot ht equals to what? Max of t dot ht, comma, what? F dot ht plus 1. So t dot st. So find the max of t dot st and f dot st. T dot st, f dot st. Max value is 2 plus 1. 2 plus 1 equals to 3. So t dot st equals to 3. Okay. So here we'll find e dot ht. Here height is 4. Here height is 4. So how to get e dot st equal to 4? So simply find the max value between e dot st and t dot st plus 1. So e dot ht equals to max of what? E dot ht comma t dot ht plus 1, right? So max of e dot st and t dot st. Here max between e dot st and t dot st is 3 plus 1 equals to 4. So height is 4. Okay. So this is the given question for HGT that calculate the height of the parse tree. Okay. So in this way we can design. In this way we can design the syntax related translation. So this is the HGT. This is context free grammar, and this one is the semantic rules, and this one is called as annotated parse tree. Annotated parse tree. Okay. So for today's, this is the last question. Okay. In the next class, we'll discuss one more example of syntax related translation. Okay. Thanks for watching.